So what are network devices? Network devices are devices that help in facilitating communication between different parts of a network. Okay, for like, let's say for example, for your computer to communicate with another computer, your computer needs a device that will help that communication to take place. For your computer to share data with another computer, your computer needs a device that will uh, help in sharing that data. Okay, so what is the importance of uh, these network devices? Ensure that data transfer is smooth. There's smooth data transfer. They ensure that there's network security. They also ensure that there's connectivity. Okay, so some of the examples that we'll be looking at are routers, switches, access point, and firewalls. Those are some of the examples we'll be looking at. Okay, so the first thing we have here is routers. Um, Router plays a very important role when it comes to network. Okay, without your router, you will not be able to browse. So apart from helping you gain access to the internet, the router also help in directing packet. Okay, when we talk about packet, like I said the last time, we're talking about data. We're talking about information. Okay, so the router helps in directing data packets between networks. If you want to send data from one network to another, it is the work of the router to help you and direct that packet to the right person. Okay, so if you look at the screen, you see that's a picture. That's how a router looks like. Though there are other routers that don't look like this, but this is just an example of what you might see. Okay, they come in different designs, different shapes. Okay, so routers they come in different designs and shape. Most companies that make routers, we have, I think, Huawei. Then there's Data Link. We have Cisco. Then some of these our internet service providers. They are also making routers like MTN. They have their own router. Glo have routers. Um, Airtel and maybe Nine Mobile. All these other networks, they have their own routers as well. Okay, so the function of router is to help in routing. Okay, routing is like deciding the shortest possible route to follow and deliver a data as fast as possible on a network. That's what routing simply is. Okay, so it also help with network address translation. As we go further, I think tomorrow you understand what is network address translation. They call it NAT. Okay, it is also through route. Is that security that decide who comes. I said we have Cisco, we have Juniper, TP-Link, MTN, Airtel, and other networks. So another device that we're looking at is the switch. Okay, you know, when we were talking last week, we talked about types of network where we mention LAN, we mention WAN. So switches are known to be like the backbone of local area network. That's the LAN. Okay. LAN, they are like just small networks, either within your house or within a small office. Okay, if you look at the screen, you also see like the picture of a switch. Okay, switch is like switch can be likened to the extension box in your house. You know, the extension box that you plug on the wall, then you are able to plug more appliances. That's what you can liken the switch to. Okay, so with this switch, you can be able to connect more computers to a particular router. Let's say you have just one router and you want to connect a lot of computers. It is with the help of a switch that you are able to share that particular router to different computers. Okay, so the functions of switch, it helps with MAC address learning. Okay, like I said, from our tomorrow's class, you understand how most of these things really work when we're talking about IP addressing, and how your computer is able to decide the destination of where it's supposed to send data and all of that. So it helps with MAC addressing, VLAN support, and data packet forwarding. So when you send an information, let's say you are sending information to a particular computer, that information will first pass through this switch, then the switch will now forward it to the computer you want to receive the packet. So it helps in forwarding that packet. Then we have types of switch on manage. We have manage. We have POE, that's power over Ethernet. That means it comes with you don't need to plug it to a power source. This power over Ethernet, you don't need to plug it to a power source. There's the Ethernet cable powers it. Okay. Then we have firewalls. Okay, firewalls, they are also known as network protectors. So if you have your network, it is the firewall that will like I explained before. Firewall is like a kind of, it's like the security in your house. It's the firewall that will decide who will come into your house. Okay, the security at the gate, they're the one that will decide who will come into your house, and in some cases they also decide who goes out of your house. You can make a rule that, okay, nobody leaves this house, and you just tell the security that nobody leaves this house, and if anybody tries to leave, the security will stop them. So that's the work of this firewall. It monitors and controls incoming and outgoing network traffic based on the rules that you have set. Okay, so you are the one that will decide what can pass through the firewall and what cannot pass. Like for most of us that are very familiar with, that are good with computers, if you have tried to install some kind of software on your system before, you see they'll tell you firewall has blocked this application. Do you want to allow access? So you have to click allow for that application to install. And if you don't want the application to install, then you don't allow it. Okay. So firewall can be a hardware, it can be a hardware, and it can be a software or hybrid, both hardware and software. Okay, so the functions of firewall, firewall it helps in like filtering packet. Okay, so if someone is sending a packet to your network or to your computer, and you have already installed a firewall, okay, you have installed a firewall, the firewall will filter the packet and check if this packet or this data is safe for your computer before it allows it into your computer or into your network. Okay, So firewall also prevent intrusion. Okay, like intrusion. When we talk about intrusion, we're talking about like a thief, someone trying to enter your house without authorization. So firewall will prevent that, just like a thief trying to enter your house without your authorization. Your security at the gate will not allow that. Sorry, I'm having cough. Okay, so the next device we're looking at is wireless access point. Wireless access point. So the way this wireless access point is, it looks like a router. If you don't read what is written on it, you might not really know the difference. Okay, it looks like just like a router. So what the wireless access point does is, if you have a network, let's say you are staying like in an estate, okay, so you're staying in an estate, and the network is the network you have is not going around the estate. Okay, maybe some people are getting weak network, or the strength of the network at their own end is not really strong. Okay, you have an estate with a network, but the network is not strong at some places. So what you can do, you can get this wireless access point and install it at those places. It will help to extend the network so that those people can get a stronger signal. Okay, that's one. Wireless access points can also help you to convert a network that is not wireless. Okay, like network that is not a wireless network. You can use a wireless access point to convert that network to a wireless network. So that people can connect to the network wirelessly. Okay, so there's difference between wireless access point and router, is that wireless access point does not perform routing. I already explained what routing is. The function of wireless access point is simply to extend the network and increase the strength of the network. It does not perform routing. Okay, so it is not a router, though it looks like a router. It is not a router. So this can be used in offices or at homes or even in public spaces. Okay, if you go to some places, you see they write free Wi-Fi zone, or they write Wi-Fi zone. So this is what they use in extending that network so that it can go around and reach everyone with a better and stronger signal. So before we go to Packet Tracer, let's just look at some of the cables that are used in networking. Okay, a cable is the physical medium through which information usually moves from one network to another. Networking cables are used to connect one network device to other, or connect two or more computers to share a printer. Okay, so these are the types of network cables that we're looking at. We have the twisted pair. This is the common one that if you have been to so the twisted pair, it has four um, each of the wires is a pair. Each of the wire is a pair, so it has four pairs of wire inside. And if you look at the image just above where you have the blue, there's another blue stuff up there. That's the connector. And that connector is called RJ45. RJ45. Okay. We have RJ11, which is the smaller version of this RJ45. Then we have the coaxial cable. Okay, the coaxial cable, this one is just a single cable, a single copper conductor at the center. Then there's a plastic, this thing around it. Then there's another kind of like a braided metal that is shielding that plastic stuff. Then we now have the insulator outside. Okay, this cable is the one you use for your decoder at home, for your dish, maybe a DSTV or Go TV dish. This is the cable you use. This is the cable that is used for that. It's called the coaxial cable. Then we have the fiber optic. This is the fastest, like it's very fast. It can transmit data at a very fast rate. Okay. Fiber optic cable consists of a center glass core surrounded by several layers of protective materials. Fiber optic are being employed in our modern day GSM telephone system, cable TV system, or internet. They are also used for transmitting information from one place to another at high speed and with less signal loss. Can you imagine transmitting data at a very long distance and not losing any signal at all? Like, should tell you how good this cable is. Okay, fiber optic cables are long, thin stranded of very pure glass about the diameter of a human hair. They are arranged in bundles called optical cables and used to transmit light signals over long distances. So if you want to transmit data over long distance, this is the cable that you can use for that, the fiber optic cable. Okay. So tonight on our packet tracer, this is what we'll design a simple network like this, and I will show you how to configure the router and how to configure each and every of those sites, just like a simulation tool where you can design your network, okay, before you go and implement it physically. So you can design your network here, simulate it, and see the devices you will be using and how you will use it before you now go and implement the network physically on ground, like physically. So when you open Packet Tracer, this is how the interface looks like. It's just blank. Okay. Then up here you have the menu bar, and where you have one or two tools. Okay. So this is like your selection tool. Then here you have the delete. I don't know if you can see my mouse moving. Can you see my mouse moving? At the bottom left, that's bottom left, you see where we have different devices. The first thing we have here is network devices. Okay. Then second, we have end devices. We have components. Then we have connectors, files. Then this is multi-user connection and all of that. Okay. So to create that network that I showed you on that picture, first of all, you come to where you have network devices, select network devices. Okay. Then you pick any of this router here. You pick any of this router. For this situation, for this what we're doing, let's just use something like this. Let's use this. And we need just one router for this particular network. Then the next thing we need is a switch. Let's use 2960 switch. Okay. So we need another switch. Please just follow carefully so that you don't get lost. Last week I asked you guys to download this on your system. I don't know how many of you downloaded it. If you did, you can be following with your own system. Okay, so I'll have two switch. Okay, so for this packet tracer, if you put a device on the screen that you don't like, that you maybe by mistake you don't want to use it again, you can always come here where you have this X, that's top left, where you have the delete. You select that delete, then you click on the device. They'll now ask you, do you want to delete this? You click delete, so it's gone. Okay, then you go back to your select tool. So I just thought I should show you that in case you put something that you don't want, you can always delete it. Okay, so we're going to be using two switches. I believe we already know the function of switch from what we just discussed. We know the function of a router, we know the function of a switch. So the next thing we are putting now is end devices. Okay, so under these end devices, we have different types of device. It can be a laptop, server, printer, anything, television, whatever you want. But in this situation, we're using PC, that's a computer. So for each switch, we'll connect just two computers. Then for this other switch, we'll connect two computers. The second switch, so each switch will have two computers, each switch two computers, but they are all going to be connected to one router. They are all going to be connected to one router. Okay, so now that we have finished placing all these devices, we started with the router, the two switches, and we now have our end devices, which are computers. Okay, so to connect your computers, you use connectors. Okay, this is where we have connections. This item that is like a lightning bolt, that's bottom left. You click on it. So by the time you click on it, you see that we have different type of wires here. If you hover over a particular wire, you see the name. Like this is copper straight through. This one is console. This is copper crossover, fiber. Then we have phone cable, coaxial, serial DCE, serial DTE, octal. So you can just, with time, you master all the cables and know which one is which one. Okay, so you just hover over any of the cable, you see the name of the cable, it will show. And if you don't know the particular cable to use, just click on this Thunderbolt sign. That should be the first sign here. Click on it. Click on the device you want to connect. Okay, then drag it to the next device. It will connect automatically. Okay, so if you look at this cable, you see there's one green, there's a green, something green here, and at the other end is showing like orange. Okay, that means the connection on the PC has been established, but the connection at the switch has not been established. When the connection at the switch is established, that orange will also turn to green. If you check, it has turned to green now. Okay, so let's connect the second one. You'll see what I'm talking about. Can you see it's still showing orange? So after some time, it will turn to green. That means it has established connection between the computer and the switch. Okay, so let's connect the switch to the router. Let's connect the second switch to the router. Let's connect this to this. Okay, so I just hope we are following. I hope we are all following and we are seeing what is happening on the screen. It's very simple stuff. You can do it if you have your computer, and this is one of the reasons why I kept emphasizing that we should use our computers for this lesson. Most of the things we'll be doing, you definitely see that you need a computer to achieve it. Okay, so if you look at the connection we have done, you see that from the PC to the switch, from the PC to the switch, you see from PC to switch, everything is green. That means connection have been established. PC to switch, green. From the PC to the switch, all these ports have turned green. The ports have turned green. That means connection is established. Okay. Mind you, this green stuff you are seeing on the line is indicates the port where the cable is connected to. Okay, so it's telling you that connection to that port has been established. Connection to that port has been established. But if you check for the router, from the switch to the router, you see that the connection has not been established because we have not configured the router. You know, when you put router, you have to configure it before you can use it. Okay. So by the time we finish configuring the router, you will see that all this stuff that is showing red will also turn to green. That's if we do the configuration well. So please follow me carefully as we do this together. For those of you that have your system already, you can follow along and also do. That's how you can quickly learn this. Okay, so we'll start by configuring the router. Then we'll now configure each of these computers. Okay, and you can also label the computers. Maybe this one now, just double click on it. You can type maybe system 1. You can start system 1, double click system 2. This is not compulsory. This is system 3. Just double click and type system 4. Okay, so this is just for clarity, so you can label your computer so that you mind you, this stuff we're doing, this is something you can also do in real life. Okay, if somebody hire you now to come and set up a network in their office, this is what you are going to be doing. So you are going to first of all configure, you draw this sketch so that when you get to the office, the first thing you do, you go to the office, study the office, and so that you know the kind of sketch you will do. You do your sketch. When you get to the office, they have bought their system, routers, and all the switches you need. This is what you'll be doing. Then you start your configuration one after the other. You can also label their system just the way we are labeling it like this. Okay, so let's go to the router and configure it. So first, just double click on the router. When you double click on the router, this will pop up. I hope we can all see. This will pop up. Okay, so you go to CLI. If you look up, you see where we have physical config, CLI, and attribute. Go to CLI and click on CLI. So when you click on CLI, you see some write-up will pop up like this. Then the last line here, they are asking, would you like to enter the initial configuration dialog? You type no. No. Then you press enter. Okay. You type no, then you press enter. So after this, you press enter again. It will take you to this point where we are now. You can see something on the screen. The last line is showing router. So what you type here is enable. Okay, so when you type enable, you press enter again. So what we have done now, we have enabled the router. We've enabled the router. Okay. Then the next thing you type here is configure terminal. So you type configure terminal. Then you press enter. Then you see they'll tell you enter configuration commands 1 per line, end with CNTL/Z. Okay. Then you see that router config hash and what have you. So we're going to name the interface that we are configuring. Okay. So we have interface. We'll name this G0. Not like 0 as in alphabet, 0 as in a number. Okay. Then /0. Then you press enter. So the next thing we'll configure is the IP address. So for IP address, I'll put 192. Don't worry if you don't understand why we're using this very particular IP address. Tomorrow we'll discuss IP addressing. We'll discuss IP addressing and you'll get more clarity on this. But just know that this is what you use. So I'll use 192.168.1.1. Okay. Then I'll put a space 255.255.255.0. This 255 is what we call the subnet max. So we'll also discuss that in our lecture tomorrow. So once I'm done with this, I'll press enter again. Then I'll type no shutdown. No shutdown. No shutdown. Then I'll press enter. Okay. So if you read, you see they wrote link 5 change interface gigabyte Ethernet 0/0. That is what we put here. That G0/0. We're labeling it as gigabyte Ethernet 0/0 has changed state to up. That means it is working now. Let me move this to the side. So if you look at that particular port, gig 0/0, you see it has turned green, but the other port is still showing red. I don't know if we're all following. So if you look at that's to the left, you see that it has turned green. That means it is up. It has changed state to up. That means it has been configured now. Okay. So you press enter. You press enter. Then you type exit to exit that port, so that you leave that particular port and go to the next port. Okay. So now let's configure the second port. which is gig 0/1. So it's the same procedure, just like we did earlier. So you type interface G 0/1. You press enter. IP address. Mind you, this is case sensitive. Not case sensitive, is you must be careful with the spacing and the spelling as well. So IP address. So for this second port, we're going to put 192.168.2.1. This is different from what we use in port 1. We use .1.1. On this one, we're using .2.1. And the subnet max will be the same, 255.255.255.0. Okay. Like I said, I will explain all of what this subnet max is tomorrow in our tomorrow's class. So once you're done entering all of this, you press enter, then you type no shutdown, and then you press enter. So you see that Ethernet, gigabit Ethernet 0/1 change state to up. Okay. That means if you look at the screen, you see it is changing to green as well. Okay, you see that it is changing to green. The site of the router has changed green, remaining the site of the switch, the port that is connected to the switch, that has changed to green as well. That means we have finished configuring our router. So that is how you configure the router. If you have more than one switch connected to the router, you go to the next switch again and do the same configuration. But the IP addresses you are using cannot be the same. The IP address you use for each port will change. Okay, so let's close this. So the next thing we are going to configure now is the computer. Okay, so let's start with the first system 1. We label this system 1. So just double click on it. Then this will come up. Select desktop. Okay, where you have desktop, just click on desktop. Then the first icon here, which is IP configuration, you click on IP configuration. Okay. So the IP configuration for this first network, which is on the first switch, we're going to have 192.168.1.10. Okay. You can use anything you want, but this is what we're using. The subnet max remains the same, 255.255.255.0. Then the default gateway is that IP address that we use in configuring that this first port here. That should be your default gateway, which is 192.168.1.1. If you remember the default gateway that we imputed. So we're done with that. You close it. Then you go to the second system 2 and do the same thing. Desktop IP configuration. So here I'll type 192.168.1.11. I use 10 in system 1. I'm using 11 on system 2. The subnet mask remain the same. Then your default gateway is the same with that port because this switch is still connected to that same port. So you are using the same gateway that you use on system 1, which is 192.1 168.1.1. So now we are on system 3. Double click, go to desktop, IP configuration 192.168.2.10. Okay. I know maybe at this point you are getting confused. Why I'm putting this, because that is what we use when we were configuring this router, the port of the router that is connected to this switch. So that's why I'm using that. The subnet mask remain the same, 192 gateway, default gateway 192.168.2.1. So let's close this. Then we configure the last PC 192.168.2.11. Default gateway subnet mask remain the same. Default gateway 192.168.2.1. So we close this. Okay, so we have finished configuring all the device. For your switch, you don't need to configure anything on the switch. Like I said, your switch is just like an extension box where you just it's just to make sure that you can connect to help you connect more computers. Okay, if you have just one computer that you want to use, you definitely might not even need a switch. You can connect the computer direct to your router and it will work just fine. But because we have more than one computer that we're using, that's why we're now using switch, so that we can have an extension. Okay. Each switch now can carry up to maybe 24 computers, 16 computers, 8 computers, depending on the size of the network that you're working on. So the switch, like I said, it serves like an extension cable box. Okay. So now that we're done with this configuration, let's so we're now going to confirm that data can actually flow through this our network. Okay. We're going to confirm that data can flow through the network. And to do that, you come here and carry this simple PDU. Okay. We carry this simple PDU. It's just like a data that you want to send. You can see the sign, there's envelope sign. So it's just like a data you want to send to someone, like a message or whatever kind of data it is. Okay. So what you do, you just drag this. Let's say I want to um say I want to send this from system 1 to system 3. Well, first of all, let's test if it can send to the router first. Okay. Let's first test if it can send to the router. Okay. So what you do, you just drag this, click on it, drag it to system 1, then you click on router. Okay, so it has sent to the router successfully. And to confirm that, you can check the bottom, right bottom, to the right corner at the bottom. You see successful. Please, if you are following, just type yes in the question section so that I would know you are following. If you can see that successful message, when I send a message from, okay, so only Abdul Salam is typing yes. Other people are not seeing. Kingsley, okay. So now let's try sending a message. Let's try sending the message from system 1 to system 2. Okay. Now I'm sending a message from one network to another network. Okay. You know this, like this, if you can see my mouse, this is a network. Okay. This everything that is connected to this first switch is a network, and everything that is connected to this second switch is another network. So let's try sending something from system 1 to system 3. So you do the same, carry this message, click, then let's click on system 3. So if you look, it's saying message failed. Message failed. Message failed. So what I will do, I will just try to fast forward the time. Maybe the connections have not gone wrong. So I'll fast forward the time, then I'll try again. Okay, system 1 to system 3. So if you check now, you see it's successful. Okay, from system 1 to system 3 is successful. Let's try system 1 to system 4 is successful. Okay, system 1 to system 4 is failed too. So let me do forwarding and try again. System 1 to system 4, successful now. Let's do system 2 to system 4, successful. Let's do system 2 to system 3, successful. So you can try from different systems. System 1 to system 2, successful. This one is within the same network. And you can also do maybe system 3 to system 4. So it's successful as well. Okay. This is how you do a simple network using a packet tracer. So I would like us to, if you have your system, design this same network and try and run this same configuration. Do a screenshot of this with all these messages at the bottom that is showing either successful or failed. Screenshot your network just exactly as you're seeing on the screen and send it on the Telegram group. Let me know we are moving together.